Okay, question 11, Euclidean geometry question. Hey, this question 11, ukwatile. Yo, very angry, very angry. I wonder ukwatiso ubando question 11. Okay, description box, more recordings for this exemplar paper. There's also a link to another YouTube channel for ama lessons. Check it out. I'd appreciate now we are subscriber to that one as well. Yeah, nangabe enjoy the content, leave a like. Nangabe new to this channel, please consider subscribing. Nangabe une question asikhulume in the comment section. Okay. A lot has been said, lovely statement. A lot. Asizokuthi bathini ke. DE is a tangent to the circle at E. Now E, this is the tangent. And then DH is a tangent to the smaller circle. It's not two yama tangents. This one and that one. I don't see any other tangent. Maybe OHF, but let's continue. But so far we are told about two tangents. Chord HK is extended to meet the larger circle at E. F and K are the points of intersection between the two circles, with FK produced to D, which GK is a chord of the smaller circle, with FE a chord of the larger circle. HF, GH, and GF are joined. Okay. A lot has been mentioned, as I've mentioned before. Interesting, they mentioned a lot of things, but just pay attention to lama chords kakhulu, ne? Pay attention to lama chords kakhulu. Why? There's a lot of lines, there's a lot happening. There's a lot. Busy le diagram. Yabona? Just to yabona uma uzozithola in an exam setting kanje ubona ama lines angaka, you uzopanica a little bit, uba like yo, where do I even start? Just narrow down your perception of lelo kanje le question, yabona. Work with what is manageable, like ama tangents with for now. Of course amanye ama lines they're gonna help out a lot. Another thing engibonayo la, it's also the cyclic quad, UHGFK. Abayimentionanga in the statement, but through observation we see ukuthi this is a cyclic quad. It's a quadrilateral inside a circle, a toucher, the circumference how many times? 4 times. That qualifies to be a cyclic quad. So another thing engaba useful in lokho, yabona. So look for such details nje, yabona. Hey, cause le diagram is busy and ikwatile futhi. Complete the following statement. D3 is equal to plus exterior angle of triangle. So it's the theorem AT. I have an interior angle A and another interior angle P. When added, they're gonna give me the exterior angle C. Right? So C is equal to A plus B, exterior angle of a triangle. So I can see that to D3 now, right? But we exterior angle for which triangle? This one here, this one right here. Remember? This one right here. H1, no, H1. This angle H1, come on. H1, no E1. When added, they're gonna give us one D3. So that's the theorem, the exterior angle of a triangle. So sizothi ke lana D3, you are actually equal to H1 plus E1, exterior angle of a triangle. Here we go. 11.2. Prove that DEFH is a cyclic quad. Who's that? I see highlighted maybe. So DE FH. let me use maybe red, yeah, red, D, E, F, H, then D. Now, so alright, so it's this one, it's this one. Okay, so they want us to prove actually this is a what? Is a cyclic quad. Okay, so where do I start now? Where do I start? Okay, so a cyclic quad we prove ngendlela ezi-3, right? Prove ngendlela ezi-3. The first one being the one yokuthi angles in the same segment, by proving ukuthi maybe say for instance that F2 no E1 ama angles alinganayo, then you just proved ukuthi this is a cyclic quad. Number 2, it's using the exterior angle of a cyclic quad. If ubheka kahle la, for this cyclic quad in question, we have 2 exterior angles. H4 plus H3, it's an exterior angle. If I can prove ukuthi this is equal to this, I just proved ukuthi this is a cyclic quad. We also have another exterior angle with D3 equal to that. We just proved ukuthi this is a cyclic quad. Or you can use the third method yokuthi the opposite angles in a cyclic quad are supplementary. If we had an angle la, for instance, so I add another angle, we so prove ukuthi this is a cyclic quad. Ngoba nakahlangana, they should give us 180. You do the same nala, take this angle, add it to this angle, you should be getting 180. Okay, so ngizokutshela ukuthi which idea will work best la. I'm gonna show you. So the first 2 methods are the most possible one. This one and this one. 3, anyaka sebenza ngoba we don't have any angles. We're not given any angles. But what we can do, mina ngithi, since we calculated the exterior angle with D3, the one go 11.1, so we can use the exterior angle one, right? Method number 2, saying that, hey, we can prove my exterior angle. Back. Check this out. This is a tangent. Yes, it is a tangent. This is also a tangent. This is also a tangent. So check out manje. We just proved this. Ukuthi D3 ulingana no H1 plus E1. We just proved this. We just proved this. So what we can do manje is find a way of showing that this is equal to that. The tangents are gonna come in handy here, Angela. Back. E1 ulingana no F1. How do I know? How do I know? E1 ulingana no F1. How do I know? The 10 chord theorem. This is a tangent, DE tangent. Hence I kept on emphasizing that. Narrow down information yakho. So E1 no F1 bayalingana. It's a 10 chord theorem. 10 chord theorem. So E1 ulingana no bani? No F1. Okay? You write down the reason. 10 chord. 10 chord. And then we also have another tangent la. H1 ulingana no bani? No F2. Again, 10 chord theorem. You have a triangle inside ilukanji circle yakho touching the circumference 3 times. So uno H1 equal to F2. Again, 10 chord reason yethu for having lama angles to be equal. Okay, so therefore remember sifuna ukukhombisa ukuthi loku ulingana naloku combined. So since bega D3 is equal to ubani. What is h1 equal to? It's equal to f2. Let me replace h1 no f2 plus e1 is also equal to bani f1. Let me replace e1 no f1 wam. So my d3 is equal to f2 plus f1. Voila, 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 voila. Therefore it means that DHFE is a cyclic quad. Is a cyclic quad. Is a cyclic quad. How did I prove this? The exterior angle of a cyclic quad. Cyclic quad. Exterior angle of a cyclic quad. Okay. Okay, we have a cyclic quadrilateral lana 11.2. Next question, 11.3. Lana 11.3. But prove that DF, where's DF? Okay, this line, I think 7 say a green this time. DF, now DF is equal to what? No, DF bisects HF, meaning that we have to prove with lama angles lawa ayalinga. We have to prove that this is equal to this, right? The word bisect simply the word bisects means ukuthi a line goes through an angle, then igamula, or it breaks that angle into two equal angles. So we have to prove that. Okay. Okay. Okay, where do I even start, Marala? Where do I even start? Whoa, okay. Remember, Lana, okay, not 11.1, but this one. It's going to help us to calculate the next one. We just proved this DEFH is a cyclic quad. We just proved that this is a cyclic quad. This is a pattern in quite a lot like my Euclidean geometry problem. Whatever you calculate on the previous question, you're going to use on the next one. Whatever you calculate here, even sometimes on the first question, you're going to use on the next one. So lagu 11.3, this cyclic quad is proved quite a lot. Okay, big. Remember siteni, in fact, let me say E1 ulingana no F2. E1 is equal to F2. How do I know? Angles in same segment. Angles in the same segment. This is a cyclic quad, so le angle le izolingana na le angle le, right? So tina, our job lana ukuthi siprove ukuthi wena you F2 you are equal to bani u F1. We also proved ukuthi u E1 is equal to u F1 through the 10 chord theorem. We just proved this on the previous question, right? Therefore F2 ulingana no bani no F1 because of they have a mutual angle. They are equal through a mutual angle. Ne? They are mutual through they are equal to a mutual angle, which is ubani u E1. So this is how we prove iloganji E ama angles wethu ukuthi ayalingana. Therefore DF actually does what? Bisects. Therefore DH bisects. Okay, so you can you can also use H1 to prove. You can also use H1 to prove that the angles are bisected. So 11.4 11.4. If K1 is equal to E1, or K1 is equal to E1. Where's E1? Oh, this one. Right. Okay, so E1 ulingana no K1. Prove that GK, this GK, let me use yellow this time. GK, black. GK, they want us to prove good to GK is a tangent to the larger circle at K. Is a tangent. We have to prove that. So how do we go about proving that this is a tangent? So a tangent normally, see, proving a ten-chord theorem. Ne? So our task would be to show something like maybe something like K2, that this angle K2 is equal to body E2, this angle. Once it's going to E2 lingana no K2, guess what? We just proved this is a 10-chord. It's a tangent through the 10-chord theorem. Okay? Through the 10-chord theorem. But the question is, where do we even start? Okay. Yeah, this is a tricky one. This is a very tricky one. Alright, but akhluphi. Eish. Yeah, the question be kwatile la question 11. Okay. Okay. Check this out. Okay, kenze kahle nga highlighter la. Now I'm having an idea. Check out this one. Let me also highlight ama quads akhona, ama quadrilaterals akhona. Let's use maybe this color to highlight the quad tonight. This is the quadrilateral number 1. We just proved this one. Good question 11.2. Green, I'm gonna highlight another quad. It's this one, the green one. It's a cyclic quad. This green one, it's a cyclic quad as well. Okay, it's a cyclic quad. The reason why I highlight a cyclic quad, it's because of the way I highlight ama angles swam corn. They showed us with the wena you are equal to wena, and at the same time we wanna show that wena you are equal to wena. Yeah, so I'm thinking, how about we use ama exterior angles of the cyclic quads? We can start with okay, so the orange one only has an exterior angle. Okay, but let's start there. So H4 plus H3, H4 plus H3 combined are equal to bani E1 plus E2. When an angle as an exterior angle, you are equal to these two combined. Exterior angle of cyclic quad. Exterior angle of cyclic quad. Okay, so okay, let me just continue. Let me continue. Because if I start talking, trying to explain, it's gonna be a bit of a problem. We are also told, in fact, not told, but through iloganji. Remember, this HK is a tangent. So when I H4, you are equal to K1. Tan-chord theorem. Na triangle yakhona. So the H4 is equal to K1. H4, you are equal to K1. Remember, our task is to show K2 you are equal to E2. Ne? You are equal to E2. So we are trying to create sort of like an equation of some sort, so that na substitute onto that equation, we can end up with K2 and E2 in the same equation, right? And eventually show that the K2 and the E2 are equal. So going back to iloganjet, let me see. Okay. I need more information la. H3, this angle, you are also equal to bani K2. Now we are going somewhere ke manje. Yabona manje, we are heading somewhere. We are going somewhere. H3, you are also equal to K2. Yabona? So hence I was explaining ukuthi we need ubani E2 and K1 in the same equation, right? In the same equation. And no, not to K1, K2 and the E2 in the same equation. Once ngakhombisa ukuthi lama angles are equal, bam, we just showed ukuthi we have a tangent lapha ku K. So I'm gonna go back to this equation and say, therefore, hey, when I H4, I'm gonna replace you with K1. This is the equation I'm talking about. When I H3, I'm gonna replace you. I'm gonna replace you with K2 equal to E1 plus E2, right? Plus E2. Now, in the same equation, not K1. Why do I keep saying K1? K2, no, E2, in the same equations. But, of course, we are told in the equation with the K1 and E1 are equal. These two are equal, right? It means bazo cancelan. When I transpose E1 over to the left hand side, or let me say, ngoba bayalingana, I can either replace K1 ngifake E1. They are equal, right? They are equal. Or I can replace E1 ngifake K1. Instead, I'm gonna say replace our K1 with E1 and say plus K2 equal to E1 plus E2. So we have two equal variables. Logo kuzocancelana eventually. Whether I transpose to the left or to the right, they're gonna cancel. I'm left with K2 that is equal to bani K2. Voila. Therefore okay, GK is a tangent. GK prove that GK is a tangent. I just proved that GK is a tangent. Normally we refer to this as the inverse. It's not the inverse, it's converse, man. The converse of a 10 chord. We just showed what lama angles are linear, right? So therefore this is a tangent. If particularly this is a tangent, lama angles azo linear. So it's just straight tan chord theorem. Okay, so question 11, this is where we conclude our discussion. Ngishizwa ngathi 11.4 ukwatile. Wenze le question yaba English. So yeah, thanks for tuning in, thanks for watching. I hope you enjoyed this video. Ungakhohlwa ukulike, ukushare, nokusubscribe. For now, asibonane on the next recording. Bye bye.